Hello, everyone. I will start with the recap and then we'll continue from where we left on Sunday. So, we are starting with the object oriented programming in Java. We'll first talk about what are objects, what are classes. So, object is basically an instance of a class that has methods and properties. It's nothing but a real world entity that can be distinctly identified. And a class is basically a blueprint that defines data fields and methods. Data fields are also called member data or instance variables, and methods are also called member functions. What are the advantages of member data and member functions within a class? Well, member functions and member data are kept inside the class to restrict their access from outside. This avoids accidental modification. So it promotes data hiding, which is ensuring that we keep the data inside the class. The definition of member function or methods inside the class provide the scope of modification in the definition of a method without affecting the outside world. What care should be taken in OOP? So when an object is created, it's created as a reference of another object when the class is instantiated. So we need to be careful because the object is a reference. So if you make a change in the data member of one object, it will be reflected in the second object also. So in Java, one object can be used as a reference to another object of the same type. Both are of the same class type. When objects are used as a reference, one should take care while performing operations on object, because if there's any change in data in the member values of one object, values of the respective data of the second object also get changed. How is an object created? Well, there are two steps which can also be combined. First is declaration, and second is instantiation. So in the declaration, you just give the data type, which is in this case student. Student is the name of the class, and student one is the variable name. You can choose whatever variable name you want. So that's declaring the object. And then second is instantiating, where you put the variable name which you have added in the step one equals new, the name of the class, and the round brackets. This is the time when the memory is allocated, when you use the new operator. So first an object is created as a reference, and then second, in the step two, the memory is allocated. You can also combine these into one line, which is shown over here. Okay, so first only a reference to the variable is created, and at this stage no actual object exists. When a new operator is used, the memory is allocated for the actual existence of the object. The new operator in Java is used to dynamically allocate the memory for an object. It returns a reference to the object and also binds the reference with the object. Okay, let's continue. What are the difference between classes and objects? Well, objects have the states and behavior, while class describes these states and behaviors. For example, cars, dogs, humans are objects of a class species. A dog object of a class species can have its state and methods. States are also called properties, and behavior is method. For example, for a dog, it could be barking, wagging the tail, running, etc. Now let's talk about data hiding. Well, data hiding means showing just the essentials to the user while hiding all the details. So it enables the developers to protect their data and hide implementation details from the outside world. To implement the data hiding, variables in a class should have private access modifier. So when someone needs to access or modify private variables of a class, they should only be accessible using the get and modified using the set method. So what are getters and setters? Ideally, if you declare a variable and give its member access as private, it cannot be accessed from outside the class into its child class. In order for us to do that, we have to use the get and set method. The job of the get is to get the data or the value of the variable, and the job of set is to modify or change the value of the variable. So private variables can only be accessed within the same class. However, it is possible to access them if we provide the public get and set methods. The get method returns the variable value and set method sets the value. Then we can use those methods, example get name and set name, to access the value of the private variable. So let's take an example. There's a class called person. We have a private variable called name with the type string. If we try to access it, like if we try to change the name value in after instantiating it, you can see that we get an error. We try to print it, we get an error. So to solve this, we create two methods in the same class, which is get name and set name, with the public as its access modifier. And then we'll be able to set the value using the set name and get the value using the get name after we instantiate that class. Okay, let's talk about abstraction and using abstract classes. So data abstraction is a process of hiding the detailed information and only presenting the essential information to the user. For example, a car can be viewed as a car rather than its individual components. Abstraction can be achieved by using abstract class or interfaces. Any user can use a method without knowing about its implementation details. Okay, let's continue. So in the abstraction, for example, the implementation is the body of the method black box is hidden from the user. So user doesn't have to care as to what is going inside of the method body. All he cares is that if he's giving an argument to that function, it should do something and return its value. For example, sending SMS where you type the text and send the message, you don't really care the internal processing about the message delivery. Abstraction lets you focus on what the object does instead of how it does it. Now we talk about the abstract class. Any class that is defined with a keyword called abstract is called an abstract class. There can also be methods called abstract. So any method defined with the access modifier as abstract is called an abstract method. Abstract classes cannot be instantiated. They can only be extended. And as you can see that here we have an abstract class and the Honda 4 class extends this particular class. If any child class extends the abstract class, it must implement its methods. So in this case, you can see that it's only defined, the run method is only defined, the implementation is done in the child class. If there were multiple methods, all methods must be implemented in the child class. It can also have abstract and non-abstract methods. It can also have constructors and static methods. It can have final methods which will force the subclass not to change the body of the method. Okay, let's talk about encapsulation. So encapsulation is basically binding the data members and methods together. So it is done securely by making the data field accessible only to the class members by declaring the data fields as private. Everyone outside the class knows how to access it and use the method without thinking about its implementation. So it's binding the data members and methods together. In Java, setter or getter methods are also used to ensure read or write only operations. Now we talk about inheritance. Inheritance means where a class is extended by its child class and the methods and the properties of the parent class are available in the child class. It provides reusability by inheriting the properties in the new class from a derived class. It is a process by which one object acquires the property of another object. It allows for the creation of a new class similar to the previously defined class, and the new class can have its own method uh, and data members, which means it can have more methods also besides the one inherited. This feature of Java supports the concept of hierarchical classification. So this is an example. The parent class is also called superclass, and the child class is also called subclass. What are the advantages? It can reduce the development time because there is reusability, less memory requirement, less execution time, redundancy can be minified, flexibility makes the code flexible to change, as you only adjust in the parent class, and any class which is inherited the parent properties, which are the child classes, will automatically have those changes. With the help of inheritance, you can override the method of the base class. You can achieve data hiding. The base class inheritance decides which data to be kept private. Types of inheritance, you have single inheritance, which means one class inherits the property of another class. Multi-level inheritance, which means one class inherits the property of another class, which is again inherited by another class. So C inherits B, B inherits A. Hierarchical means that multiple classes inherit the properties and methods of the same class. So like B and C goes ahead and inherits class A. Okay, an example. So here we have a class called animal. It has a method called eat. So dog extends animal. So this is an example of single inheritance. And then when you instantiate it, method of both the classes are available. Multi-level, you can see that dog and baby dog, dog inherits animal and baby dog inherits dog. So like in a chain. Okay. Then you have hierarchical inheritance. So you can see that dog and cat both inherit animal, and the methods are available here for meow, but it's not available for eat. Okay, member access inheritance. Often an instance variable of a class will be declared private to prevent this unauthorized usage. We've read this time and again. Inheriting class does not override the rule of private access restriction. Thus, even though child class includes all of the members of its superclass, it cannot access those members that have been declared private unless we use the getters and setters. I talk about polymorphism and its advantages. So poly means many, morphism means form. So an object that can take multiple forms is called polymorphism. It allows one interface to be used for a general class of actions. Polymorphism principle is implemented in Java programming with methods of overloading and overriding. Overloading allows one method to be used multiple times with each time with a different signature and parameters. Overriding work together with inheritance to enable code reuse of existing classes without the need for recompilation. Which means if the parent class has a function, the child class can have the same function with the same name but make it do something else. That's overriding. It tends to reduce the pairing of multiple functionalities. It allows programmers to reuse, evaluate, execute the program modules, forms written once. Okay, so polymorphism, we already taken a look at its advantages. Tends to reduce the pairing of multiple functionalities, allows programmers to reuse, evaluate, and execute the program modules, forms written once. Okay, types of polymorphism. So it's static and dynamic. Static is achieved through overloading, and dynamic is achieved through overriding. So static polymorphism is the linking of a function with an object during compile time. Dynamic polymorphism, in this, compiler doesn't determine the method to be executed. It's the JVM that performs the process at runtime. So static is to do with compile time, and dynamic is to do with runtime. Static uses overloading, dynamic uses overriding. Okay, an example of overloading, you can see there are different functions with the same name but different parameters being used each time. Now, on overriding, you can see that the function draw is being overridden in child classes. These three child classes, the same function is defined in parent class, but it's overridden here. And each time it's doing a different thing, which means first one is creating the triangle areas, second one class, and third one rectangle. So the name of the function is the same, but functionality is different. The use of super keyword in Java. So sometimes you'll have both parent and child class having the same function name. So to avoid confusion, if you want to call a parent class method into a child class, you can call it by prefixing it with super dot. So here, the same function, you can call it with super dot. Access modifiers in Java, there are four types of access modifiers: private, public, default, and protected. Okay. So private, the access of level of private modifier is only within the class. It cannot be accessed outside the class unless you use getters and setters. Default, if you don't define any access modifier to a class, it'll by default be default, and it's only available within that package. It cannot be accessed from outside the package. Protected, the access level of the protected modifier is within the package and outside of the package through the child class. So you can access the protected ones um, from outside the package, but you have to use its child class, which inherits its properties and methods. Public, the access of public modifier is everywhere. It can be accessed from within the class, outside the class, within the package, outside the package. So public means everywhere. The use of constructor. So as you can see, main function is definitely required in a program. A program must have a main function as an entry point. There's also a constructor. If you don't define a constructor, then it will automatically be defined under the hood by the system itself. So a constructor is used for initializing the objects at the time of creation. It is automatically called. Constructors have the same name as the name of their class. Once a constructor is defined and used for object creation, it is automatically called and the memory is allocated before the new operation completes. Main method is the entry point of the program in Java. Constructor, every class has a constructor. Even if you don't declare it, compiler will add a default constructor. Constructors allow creation of instances of a given class, whereas main method merely allows for a potential entry point for starting your program. Okay, let's talk about order of execution. Every class has its own constructor, as we discussed. Therefore, the execution of the constructor starts after object initialization. It follows certain sequence according to the class hierarchy. For example, in single inheritance, the constructor of the base class is executed first. In multi-level inheritance, all the upper class constructors are executed when an instance of the bottommost child class is created. Calling same class constructor using this keyword. Here, instance is not implemented, but there can be multiple constructor of a single class, and those constructor can be accessed using this keyword. Calling superclass constructor using super keyword. A child class constructor or a method can access the base class constructor or method using super keyword. These guys are heading, so they should be bold. Okay, moving on. Use of static method in Java. So why is this static method used? The static keyword is used to construct method that will exist regardless of whether or not any instance of the class are generated. So if there's any method called static, you can access it without using the new keyword. You can directly access it. For example, there's a change method and it has a keyword called static. So you can call this method. You can see you can call it using the name of the class dot the name of the method before even instantiating it. Okay. Any method that uses static keyword is referred to as static method. Static methods have access to the class variables without using the class object instance. which means anything that you use here, like for example, college will be available here without even instantiating. So you can use it. Advantages and disadvantages of garbage collection. In garbage collection process, Java freely dynamically allocate memory which is no longer referenced. Advantages: it can make programmers more productive, ensure program integrity. Disadvantages: adds an overhead to the system which adversely affects the program performance. Programmers have less control over the scheduling of CPU time. Now, use of final keyword. So, final keyword, when we go ahead and use it, is as good as creating a constant. So, if you declare something with final keyword, you cannot change its value. Now, finalize method. So, finalize method in Java is an object class method that is used to perform cleanup activity. So, before destroying the object, it is called this finalize method. It is also called garbage collector before destroying the object from the memory. Finalize method is called by default for every object before its deletion. So before the object is deleted, this method is automatically called. So you can do all the cleanup work here. This method helps garbage collector to close all the resources, for example, closing the database connection used by the object, and helps the Java virtual machine in memory optimization. Features of Java: based on the object oriented programming concepts, everything in Java is an object. Objects promotes understanding of the real world problem in a natural way. They provide practical basic for implementations of the design system. It's simple and secure. It's easy to understand, write, and having the user-friendly syntaxes. We can develop a virus-free system using Java programming language because it has no explicit 9 pointer. It runs inside of the virtual machine sandbox. It's portable, so it facilitates you to carry the Java bytecode to any platform. With the help of the bytecode, you can run a Java program on any computer virtually. Provides three types of portability. One is source code portability, CPU architecture portability, and OS or GUI. It's robust. It provides an automatic garbage collector that runs on the virtual machine and destroys the object which are not being used in the program anymore. It's multi-threaded. Java runtime systems comes with an elegant solution for multi-process synchronization that enables you to construct smoothly running interactive systems. It's architectural neutral, which means JVM was designed to write once and run anywhere, anytime. Interpreted in high performance, the bytecode can be translated into native machine code using just-in-time compiler, which is faster than the standard JVM. It also facilitates running one time and caching the results for future. Just a quick recap. It's simple and secure, portable, robust, multi-threaded, architectural neural, interpreted in high performance, etc. Okay, so this is an architectural neural. First is your Java code file. Then you have a Java compiler which converts your code into bytecode. Bytecode is then run by any Java virtual machine, either Windows, Linux, or Mac. Also distributed. After compiling the Java program on one machine, it can be transferred to another machine to execute because of its bytecode facility. So same bytecode can be run onto any machine. That's why it's called distributed. It supports remote method invocation, which helps programs to invoke methods across the network. So you can invoke method from one network to another network. It's dynamic. Java programs carry substantial amount of runtime type information that is used to verify and resolve access to objects at runtime. This enables to link code safely and experiently dynamically. Using class loader, you can also load a newly created compiled class at runtime in a standard language supported way. Okay, development environment tool. We'll just breeze through it because I doubt we'll have questions in exam for that. So you can write, compile, and edit programs in two ways: command line environment and integrated development environment. Key components are JDK, JRE, JVM, JIT. JDK is Java Development Kit. JRE is Java Runtime Environment. JVM, Java Virtual Machine, and just-in-time compiler. So these components interact with each other to create sustainable runtime environment that enables the seamless execution of Java-based applications in virtually any operating system. So you have JDK first, inside of which you have JRI, which are Java class libraries. You have JVM, inside of which you have JIT. Every module comes with JDK. JRE is a class library. JVM is an instance of JRE. GIT is a part of JVM that is used to speed up the execution time. So just they might ask you all of this as short notes. Sometimes they put last question as like short notes. I mean, they might ask you what these are. So JDK, every module comes with that. This is a class library instance of JRE, and JIT is a part of JVM for speeding up the connection, the execution time. Okay, this is in detail. It's a software development environment which is used to develop Java applications. It contains the Java runtime environment along with development tools. It contains private JVM and other few resources like interpreter loader, Java compiler archivers, and Java doc for documentation generated to complete the development. Java runtime environment is a software layer. So the previous one was a software development environment. So JDK was a software development environment. JRE is a software layer that runs on top of the operating system, provides class libraries and other required resources to run specific Java program. JRE runtime architecture uses class loader, bytecode verifier, and interpreter. Then you have just-in-time compiler and JVM. This is an integral part of Java virtual machine and garbage collector. It can compile Java code into machine code, which improves performance. Usually compiles the code as per the requirement. Once the method execution crosses a certain limit, like 10,000 execution, then it will be converted into machine code. Programs written in Java compiled into machine language, but it's machine language for a computer that really doesn't really exist. This is why we call the virtual computer and it's known as Java Virtual Machine. The machine language for JVM is also known as Java bytecode. This code enables us to run the program on any computer. Okay, recap once again. Okay, so JDK is a software development environment for developing Java application. JRE is a software layer that provides class libraries and other required resources. JIT is an integral part of Java Virtual Machine Garbage Collector. It compiles Java code into machine code. Then this is the flow of the program execution. This is our source file. Java compiler compiles into the Java compiler first actually compiles it and then generates the class files, the source code file using the library, and then executes. This is executed by the Java virtual machine and outputs the program. Okay, data types in Java. You have primitive data type. Primitive data types include Boolean, char, byte, short, int, long, float, double. Non-primitive types include classes, interfaces, and arrays. Boolean default value is false. Default size is 1 bit. Character default value is \u 4 times 0. Size is 2 byte. Byte default value is 0. Default size is 1 byte. Short default value is 0. Default size is 2 byte. Int default value is 0. Default size is 4 byte. Long default value is 0. L suffix by L to denote it's long. and then it has 8 byte float 0.0f, 4 byte double 0.0d, 8 byte. Okay, so char 2, byte 1, short 2, int 4, long 8, float 4, and double 8. Okay, non-primitive data type classes. We already discussed about this. Class is basically a blueprint from it, which an object is created. It has properties and methods. Interfaces is actually a blueprint of a class. It has static constants and abstract methods. It's used to achieve abstraction. By interface, we can support functionality of multiple inheritance. Okay, non-primitive data type arrays. Array is an object which contains elements of similar data type. The elements of an array are stored in a contiguous memory location. This is an example of an array, like declaring an initialization int a square brackets equals new int square bracket 5, and this is where you can initialize it, and then you can loop through it and you can print it. We can store only the fixed size of the elements in an array. It doesn't grow its size at runtime unless we use dynamic arrays. So single dimensional array, you can see that this is how you declare it. List of variables of similar data type. We can access the value using index. Then you have multi-dimensional arrays, the array of arrays that uses more than one index to access the array elements. So this is the syntax where we have data type, the type of the data, dimension. I think it's better to take a look at this one. You have data type. If it's two-dimensional array, then 2 times square brackets, the name of the variable. Then you have new int and the size of the first dimension and size of the second dimension. Similarly, for the third one, you do it 3 times. Okay, difference between static array and dynamic array. Static arrays are declared before runtime and assign values while writing the code. Dynamic array is declared while writing the code, and the memory is allocated at runtime. The static array allocated memory at compile time. For example, int array declared, and then the values are assigned while writing the code. So declared before the runtime, and the values are assigned while writing the code. This one is a dynamic integer array, int. So Maya, did you have a chance to look at this one example? Hello? Okay. The size of a static array is fixed. Dynamic array is a variable size. It grows automatically when we try to insert an element if there's no more space left for the new element. Static array is located in stack memory space, and dynamic array, the memory is allocated from the heap. So a program to print the sum of array of all elements. So here's where we initialize the array int array equals new int 1 2 3 4 5, int sum equals 0. For int I equals 0, I less than array dot length, I plus plus, sum equals sum plus array I. Okay, Unicode, a 16-bit character encoding standard, and is capable to represent almost every character of well-known languages of the world. Before Unicode, there were multiple standards to represent character encoding: ASI, ISO, KOI, etc. Some character was using single byte, some two to support multinational application codes. And even same code may represent a different character in one language and may represent other character in another language. So to overcome above shortcomings, the Unicode system was developed where each character is represented by 2 bytes. As Java was developed for multilingual languages, it adopted the Unicode system. So lowest value is represented by backslash u 4 times 0, and the highest value represented by backslash u 4 times f. Okay, variable is the name of a reserved area allocated in the memory whose value can be changed. Types of variable: local variable, it is declared inside the body of the method and is not available outside. You can use this variable only within that method, and the other methods in a class aren't even aware that the variable exists. A local variable cannot be defined with static keyword. For example, this one. Then you have the instance variables, which are the variables inside of the class but outside of the body of the method. It is not declared as static. It is called an instance variable because its value is instance specific and it's not shared among other instances. So if you instantiate that class and create several other objects, its value is not shared everywhere. For example, this one, in data equals 50. Types of variable: static variable. A variable declared as static is called static variable. It cannot be local. You can create a single copy of static variable and share it among all the instances of the class. So if you, let's say, if you create a parent class and then you declare a variable as static, the same value will be available to all the child classes. That's why saying you create a single copy and share it among all the instances of the class. Memory allocation for static variables happens only once when the class is loaded in the memory. For example, static int m equals 100. This is an example of everything. Then we'll talk about operators. Sajjan, are you there? Not there. Sumaya, are you there?
Yes, can you hear me?
Oh, yeah. Can you read this variables? 1 second. Sorry, operators.
Okay. Unary, it has categories postfix and prefix.
Okay, we can skip that.
Postfix,
We don't have to read this part. I think it's
okay,
all self-explanatory. Just read
yeah.
the names. It's fine.
Arithmetic,
Hmm.
shift operator, relational operators for comparison and equality, bitwise, logical and unlogical or operators, ternary operator, and assignment operator.
Yeah, I think it's the same as a C programming, so it's fine. The statement expressions.
In Java, each statement is a complete unit of execution. For example, int score is equal to 9 multiplied by 5. Here we have a statement. The complete execution of this statement involves multiplying integers 9 and 5 and then assigning the result to the variable score.
Okay.
In the above statement, we have an expression 9 multiplied by 5. In Java, expressions are part of statements.
Hmm. So this is the whole expression which ends with the semicolon. Sorry, that's the whole thing is the statement, and the expression is the part of it. Like 9 into 5 is the expression. Okay.
We can convert an expression into a statement by terminating the expression with a semicolon. These are known as expression statements. For example, number equals 10 is an expression. Number equals 10 semicolon is a statement.
Okay.
In the above example, we have an expression number is equal to 10. Here, by adding a semicolon, we have converted the expression into a statement.
Okay. So simple logic is that anytime an expression is ending with a semicolon becomes a statement. If it doesn't have semicolon, then it's a expression. Okay. Let's move on. Hmm.
A Java expression consists of variables, operators, literals, and method calls. For example, int score equals 90. Here, score equals 90 is an expression that returns an int.
Okay.
Double A equals 2.2, B equals 3.4. Result equals A plus B minus 3.4. Here, A plus B minus 3.4 is an expression.
What is a plus b minus 3.4 semicolon?
The statement.
Correct.
If number is equal to number 2, system.out.println number 1 is larger than number 2. Here, number 1 is equal to number 2 is an expression that returns a Boolean value.
So an expression can return something, right? So for example, a plus b minus 3.4 will return something, and that's the return value of that particular expression. In this case, in this if condition, this will return either true or false. So that's why it returns a Boolean value. Here, the type of that was an integer. An integer could be anything. A score equals 90. So that's the return value of that expression. Okay. Java scanner class. The scanner class of a Java util package is used to read input data from different sources like input streams, users, and files. Okay. I'll go ahead and explain this quickly. Read a line of text using scanner class. So scanner is available in the package called java.util. Let's say we have a main class, we have a main function. Um we instantiate the scanner class by creating its object. And we know how to create the object. We first put the class name as the type of the object equals new, the name of the class, and then we put system.in here. Then basically we want to take an input from the user, and to do that we have to use the scanner class. Okay. So we ask the user to give the name, then we say name equals, so basically we create a variable of type string and set its value equals input dot next line. So this is an object which is an instance of a class scanner. Because they have created a new object, all the methods of the scanner class will be available inside of this input. So input has different methods available. It has next in next line, different kinds of methods basis what we need. In this case, what we want is that you want to take a input from the user, so we'll just use next line. And what we're going to do now is that hold the value of whatever user enters. So whatever user enters is going to be taken with this method and stored inside of name. Then we just printed whatever user has entered, and then we close the scanner. So we use input dot close. So now we can see users entered Kelvin, and then this line is printed down at the bottom. Do you have any questions on this one?
No.
Okay. So example program with scanner class. In the previous example, scanner input equals. So this is just an explanation of what we've discussed. You create an object of scanner named input. System.in parameter is used to take the input from a standard input. So that's why we pass the system.in, so that we can take the input from the standard input. It works just like taking input from a keyboard. If we don't pass this, then we won't be able to take the input from the user. So we have to pass system.in. We have then used next line method of the scanner class to read a line of the text from the user. So next line basically reads the line whatever user enters. So system.in takes the input from the user, and next line actually reads the line of whatever the user has entered, and then we're holding it inside of that input variable. Okay, then we talk about decision and loops. Okay, go on.
Decision-making statements. If-else statement is used to execute a certain part of code. The if statement is followed by a test condition, and when the specified condition evaluates to true, then the block of code of if part is executed. If the specified condition evaluates to false, then control is transferred to else part of the program. Switch case statement is used to select one statement or block from the multiple code blocks for execution. If there are n number of case values for a switch condition, then each case will have a different value. Each case statement can have a break statement which is optional. When control comes at the break statement, it terminates the statement sequence inside the switch and control transfers after the switch statement. If a break statement is not there, it executes the next case of the switch statement.
Right. So let's say there are multiple cases, case 1, case 2, case 3. If we don't use the break statement, and if it matches one condition, it's going to execute the rest of them. So that's why it's important to use break. We can also use return. Sometimes if we want our function to return something, we can directly use the return statement instead of break statement in each of those cases. Okay, carry on.
The jump branching statements are used to skip some statements within the loop or stop the loop instantly without evaluating the test condition. Used with for loop, while loop, do while loop, and switch statement. Used to transfer the flow control from one part to another part of the program code. Jump statements are of three types: break, continue, and return statements. Break statement is used to exit from loop execution and transfer control to the next statement immediately following the loop. Continue statement is used to skip the current iteration of a loop and uh, transfer the control to the next statement or end of the loop.
Right, so we are doing all of this today, but we won't be doing that as a part of our recap because I think we've already studied about all of this and we can easily explain in the exam. And I
Yes.
also believe this question came in the last one of the papers in the last exam, decision making statements. All will when we are doing a recap, we'll just read their titles so that we remember what are decision making statements. Rest, these all things we can explain easily. Okay, carry on.
While loop repeats a statement or a block of code until its condition is true. Do while loop. The statements within do while loop are executed once and thereafter the condition gets evaluated. If this condition is true, then the loop will repeat. Otherwise, the loop terminates and control is transferred to the next statement after the do while loop. For loops allow you to execute a block of statement repetitively a fixed number of times on the basis of the decided precondition.
Okay. I'll just go through this. So, program to display numbers 1 to n. We need a scanner class because we want the input from the user. So, we go ahead and create a private variable called sc, and we are declaring it as static, which means that its value will be available to other child classes also. Okay, then we declare some of the variables like number I equals 1. We set this value sc equals scanner. We pass the system dot in so that we can take the input. This allows us to take the user from the input from the keyboard. Then we ask the user to enter the number. Then we call the next int method so we can read whatever user has entered. This method allows us to read and hold the value inside number. For as long as the number value is less than or equal to 1, then go ahead and print out the number and then keep on doing I plus plus. Okay, so this is what's going to do is going to print the number from 1 to n. So if user enters 10, for as long as the number is less than equal to 10, you'll keep printing that number with a tab. So that's a program in Java. So this might come in exam, probably. I'm not 100% sure. Okay, a program to print odd numbers from 0 to 10. Again, main function. This is how we declare main function, integer n equals 10. Asking the user, sorry, just giving the message saying odd numbers from 1 to n are. We run a for loop. We check if the using the modulus operator, if the remainder is not equal to 0, then we print saying it's the odd number. Assertion and exception handling. Okay, go on.
Assertion and its use. Assertion as per dictionary means declare positively. An assertion is a statement in Java which ensures the correctness of any assumptions which have been done in the program. When an assertion is executed, it is assumed to be true. If the assertion is false, the JVM will throw an assertion error. It finds uh, the application primarily in the testing purposes. If conditional statements are used to check bug conditions reach production even after the bug has been removed, they consume CPU cycles and may be the cause of bottleneck or resource crunch. This problem does not exist with assertions as they are disabled by default. By default, assertions are disabled in Java. In order to enable them, we use the following command:
Java
Java.
hyphen em example or Java hyphen enable assertions example. That example is the name of the Java file. One second. Let me correct a few things here. It finds it application primary in the testing purposes. I think it should be for, right? Finds the application primarily for the testing purposes. Just a recap of this. Assertion means declaring positively. It ensures the correctness of the program. Let's just bold it so it just makes it easier for us to do it. Assertion is a statement in Java which ensures correctness of any assumption. While an assertion is executed, assumed to be true. Okay. If the assertion is false, Java Virtual Machine will throw an assertion error. It finds the application primarily for testing purposes. If conditional statement used to check the bug condition reach production even after the bug has been removed, they consume CPU cycle and may cause the bottleneck or resources. This problem doesn't exist with assertion if they're disturbed by default. Okay, so what they're saying in this, okay, where it go? Yeah, what they're saying here is that when you go in production, you should keep the this assertion testing as disabled, because if you keep it in production, then it's going to consume the CPU cycles for running it. Okay, so during the development phase, you switch it on, you test everything, but when you are keep pushing it in production, then keep it off. And by default is anyways off. So that's what he's talking about here. That by default assertions are disabled. If you want to enable them, just run this command java hyphen ea and the name of the Java file, or this one enable assertions. I think this is easier to remember if you had to write an exam rather than the EA. Java hyphen enable assertions and then the name of the file. Okay, carry on.
Assertions in Java can be done with the help of the assert keyword. First way, there are two ways in which an assert statement can be used. First way is assert expression. Second way, assert expression colon expression 2.
Okay, so I'll go with the example. So if you want to do an assertion, you can do it with the assert keyword. This is a syntax basically. You use the assert keyword in the expression and expression one colon expression two. So let's go with this example. So in the main function, you've declared a variable called age with the value is 14. Uh, you use assert. So this is going to, I think this is going to return a Boolean value if I'm not wrong. Let's see. Yeah. Uh, okay. If age is less than equal to 18, colon, cannot vote. Okay. System out print in the voter age is 14. Okay, let's see. Let's go further. When assertion fails, assert usually throws assertion error when the assumption is made is wrong.
It should have
Assert,
thrown assertion error in the previous program, no?
mm, age is less than equal to 18. It's correct. It will not throw because age is less than 18.
Oh,
Na?
okay, it's less than 18. No?
Yeah. So when assertion fails, assert usually throws assertion error. When assumption is made is wrong. Let's fix this. Reduce its font size and just move this a little bit down. Assertion error extends from error class that ultimately extends throwable. So there's a whole hierarchy which I'll show probably in some time, but it's just saying that this is a child class of the error class, which is again a child class of a throwable class. Catching exception error. An assert statement declares a Boolean condition that is expected to occur in a program. If this Boolean condition evaluates to false, then an assertion error is given at runtime, provided the assertion is enabled. By default, assertion is disabled. If we enable it during the development process, then if the condition is false, we'll get an assertion error at runtime. If the assumption is correct, then the Boolean condition will return true. Not kind of echoing it out, so probably that's why it's not giving true. The assertions are not required to declare them explicitly, and there's no need to try or catch them. Okay, I think exception is something we try or catch. Assertion, there's no need to try and catch them. In case if there's error, then it will throw the assertion error. In case if there's no error, the code will just continue, I think. Asserting an exception. To assert an exception, we declare an object accepted exception as follows. Public expected exception equals accepted exception dot none. Then we use the expected and expect message methods in to test the method to assert the exception and give the exception message. Exception is an unwanted or unexpected event which occurs during the execution of program at runtime that disrupts the normal flow of the program. So I think we are done with the assertion over here. Now we'll move on to exception. Just fix this. Okay, Sumaya, can you read this?
Exception is an unwanted or unexpected event which occurs during the execution of a program that is at runtime that disrupts the normal flow of the program's instructions.
When an exception occurs, yeah, go on.
When an exception occurs within a method, it creates an object. This object is called the exception object. It contains information about the exception, such as the name and description of the exception and the state of the program when the exception occurred.
Okay.
Causes of exception: invalid user input, device failure, loss of network connection, physical limitations like out of disk memory, code errors, opening an unavailable file, the JVM has run out of memory.
Yeah, so if you remember, I think on one of the previous courses, we did learn about what are the causes of exception, and they're very similar to what we're discussing here. In short, exception is unwanted or unexpected event which happens during the execution of the program. In my opinion, it's important to catch them because if we don't catch them, uh, then what will happen is that the program will break at that point. But if we handle the exception, then even if we get an error, it'll catch that exception, it'll print some message, whatever it wants to, but the flow of the program will not be interrupted, which means the rest of the program will flow. And that's why it's important to handle the exceptions. And I think this is one of the key things that we should remember when we talk about exception. This is a very, very important point. Okay. Go on.
Example of exception handling in Java. Various
Hmm.
methods of exception handling are try, catch, finally, throw, and throws. If we don't catch the exception using try and catch method, then the program will terminate at the line where we get the exception. But if we do handle the exception, then program will catch the exception and continue to run.
Yeah, this is exactly what I explained earlier. This is an important question from the assignments. So I think it's important to take a look at this. So here we have an exception handling class that we have created, custom class. We have a main function. All we have to do is just use try catch. And this is very similar to what we do in other programming languages also, except a few things like you have to put the name of the exception class here. So let's say there's a code. This is my code. Okay. My int integer dot pass int hello. Okay. So you know that hello cannot be converted into integer. If we don't use the try and catch method, what's going to happen is that we will get an error. And if we have written anything after this, any line of code after this will not be executed. Program will break. But if we use try and catch, it'll catch that and then it'll do whatever is supposed to be done in the next line of code. So here we are using try method. We're writing whatever program we're supposed to write. We're catching if there's any error. We use number format exception because this error is related to number format. E is the variable name. If you want to print the error, you can use this E and just print it out here. But usually, people don't print. So if there's any error, you know what kind of error will be. You can just directly do a print here. Finally, something that will always get executed. So catch will get executed in case if there's any error. Finally, will always get executed. Okay. So if you want to do something always, then you put that inside of finally. But it is not necessary that you have to use finally. You can just use catch. So here you can see string cannot be converted to number because there was an error, and then finally got executed because it always gets executed. Okay, carry on, Sumaya.
We can also pass exception in the catch method param that will catch all types of exception. Number format exception will only catch that type.
Right, right. So the name of the class that we are using is important to know that if we use this, we are specifying will only catch that type of exception. But if we use exception, then any type of error occurs. Now it's not specified to just int. If you're using any other thing over here, any type of exception, it'll catch that.
If we use the method finally after catch, then that code inside finally will always execute.
Yeah. Let's just fix some of the things here. I think this needs to be bold, italic, and let's just make this a little bit, in fact, not even small. We can just push this a little bit down. Here, this needs to be bold. Just makes it easier to read. This should also be bold. Yep. Let's move on. We are doing half an hour more because we weren't there last 2 days. Are you okay with continuing, Sumaya?
Yes.
Okay. We have very less time. It is 10th of August. Hardly have 16 days.
Yeah.
Okay. Let's do exception hierarchy.
All exception and error types are subclasses of class throwable, which is the base class of the hierarchy.
Hmm.
One branch is headed by exception. This class is used for exceptional conditions that user programs should catch. Null pointer exception is an example of such an exception.
So you can see there's a big hierarchy. So we established that an exception is basically an object. Okay, so everything originates from a throwable class. Okay, so inside of throwable class we have exceptions. Exception extends throwable, or there could be an error also. So right now we are discussing exception. We'll discuss error also. But inside of exception, there are other classes that extend exception. You have runtime, IO, SQL exception, AWT, and then under each you have different categories. So this is like a whole hierarchy. You can always take a look at. Like sometimes if you want to handle only a specific exception, let's say, where was the one we were discussing? Mm, yeah, null pointer exception. So it sits under runtime exception. Okay, so remember when we did catch, we specified the name of the class there. So we were very specific in saying what we want. But if we just use exception, then it'll catch any type. Okay, go on.
Another branch error is used by the Java runtime system to indicate errors having to do with the runtime environment itself. Stack Overflow error is an example of such an error.
So the right side that we see all these errors are actually used by the JVM to indicate errors for the runtime environment error. Okay, example Stack Overflow error. Okay.
Types of
Go.
exceptions.
Mm-hmm.
Built-in exceptions. These are available in Java libraries. Checked exception are compile time exceptions because these exceptions are checked at compile time by the compiler.
Mm-hmm.
Unchecked exception are runtime exceptions. The compiler will not check these exceptions at compile time. The program would not give a compilation error. For example, divide by zero, array out of bounds, null pointer exception, etc.
Okay.
User-defined exceptions. Sometimes the built-in exceptions in Java are not able to describe a certain situation. In such cases, users can also create exceptions which are called user-defined exceptions.
Okay, so there are two types of exceptions, built-in and user-defined. Built-ins are already available in Java library, so we are not the one who created, they are part of the core. One is checked exception, second is unchecked exception. Checked are compile time exceptions, unchecked are runtime exceptions. And the reason why they're called unchecked is because compiler is not going to check these exceptions. For example, division by zero, array out of bounds, etc. User defined are the one, for example, if that kind of an error is not available in the Java library, it's not fitting any of the types that are available, then we can create our own type of exception, which are user defined. Okay, let's see an example. In order to create custom exception, we need to extend the exception class that belongs to java.lang package. So here there's a class called myException. We are extending the exception class. I remember earlier in the chart also I showed that these guys are actually the child class of exception. So all these guys extend exception. So even when we are creating our own custom exception class, we have to extend the exception because that is not available anywhere here. It's like our own. So oops. We extend the exception like here. We name it whatever we want to, and we create a public method my exception. And then if you remember, super, the job of super is to call the parent method. If you do super dot the name of the method, it will call a specific method of the parent class. But if you're just using super, then it's just going to call the constructor of the parent class. So in this case, parent class is exception. Super is going to call the constructor of parent exception. Probably that constructor requires a variable to be passed. That is why we are passing the variable, which is kind of pulled from here. And then inside of our own class main, we do a try a catch. We do throw new my exception, whatever that value is, and then you catch system.caught, and then you print the message, whatever message you're going to get. So this basically, as I explained earlier, this has the information of whatever that error is. So it has certain methods available. So there's a method available called get message, so it'll help you get the message. So we can pass the string to the constructor of a superclass, which is obtained using get message function on the object created. Oops. Yeah, I think we didn't do the output of this, but yeah, I guess we'll just throw this error and just print it out. Okay, throw and throws. The throw keyword is used to create custom error, while throws keyword indicates what type of exception type may be thrown by the method. Throw is explicitly used to throw an exception, but throws is used to declare the exception. Okay, so throws is used to declare an exception. Where is it? It is throws. Yeah, throws is used to declare the exception. Throws used to throw an exception. Here we are throwing it. Here we are declaring it. Okay. Throw is followed by an instance, and throws is followed by a class. This is a class, an instance. Okay. Throw is always used within the method, and throws is used within the method signature. Clause can throw any one exception and not multiple exceptions. Throws can declare multiple exceptions. So we'll start from here. Throw an exception if age is below 18, print access denied. If the age is 18 or older, then print access granted. So we create our class called main. Inside of this, we have a static class, which means a static method, not class, a static method. Static method can be accessed by the child classes without instantiating. Then we are checking if age is less than 18. We use the throw to throw the exception. Here also in the previous example, we use the throw to throw the exception. This is custom exception basically. So throw new arithmetic exception. In this case, we are using a class that's already available inside of exception called arithmetic exception. We're passing the value access denied, and it's going to basically uh, print this, and then else system.out print ln access granted. So if this condition is not met, then it's going to print this. Then inside the main class, we call this function check age. Notice that we have not instantiated this particular class method. Sorry, class. Check age 15. Set the age to 15, which is below 18. So this is going to pass that value age, and then it's going to check the condition. Okay, let's see. I think this has been pasted twice. Yeah, I think it's pasted
It has
twice.
the throws declaration.
Oh, there are two examples. Okay, sorry. Yeah, so in this example, we're trying to achieve the same thing, but this time using throws. So static void check age throws arithmetic exception. Okay, if age is less than, then throw arithmetic. Same thing. Same thing here also. Okay, check age, set age to 18, which is below 18. Okay. So throws will indicate what exception type may be thrown by the method. Okay. Packages and interfaces, I think this is important. So may I please read it?
A package is a collection of a similar type of classes, interfaces, and subpackages in Java. It is just like a folder in a file directory.
Right.
For example, when you write an application program in Java programming language, there may be many individual classes. You can place related classes into a folder and name this folder for organizing these classes. Now it's called a package. Packages are used to avoid name conflicts and to write better maintainable code.
Okay, I think these are all self-explanatory. We don't have to repeat it again.
Accessibility rules for packages. You can limit the access of classes, methods, and variables throughout packages by using access specifiers.
Yeah, so remember we discussed about private, protected, public, and at that time we discussed about packages like if we declare it, then where it'll be available. Can it be available inside package or outside package? Some of them were available outside the package by using a child class. So that's what the rules that we're talking about here.
The three main access modifiers, private, public, and protected, provide a range of access required by these categories. You can declare anything as public, then it can be accessed from anywhere outside the package. Anything declared as private can only be seen within that class.
Or else we can use setters and getters and access them outside.
When you do not mention any access modifiers, it is called default access modifier, which is visible to subclasses and the other classes in the same package.
Right. Exact same thing which we studied in on that sheet. Uh, just repetition of that.
If you declare it protected, then the code is accessible in the same package and its subclasses present in any other package.
Okay, so just a recap. Anything that's public, public means like anywhere, inside, outside the package, anywhere. Anything that's private only can be seen as a part of the class. Even if you use a child class, you can't access unless you use setters and getters. If it's default, it's visible to the subclasses and other classes in the same package. In the same package. That's it. So for default, we have to remember that it has to be in the same package. For protected, it can be in the same package or other package, but it has to be a subclass. Okay. So again, repetition. Public is anywhere. Inside same package, outside same package, doesn't matter. Private only within that class. Default can be used with the subclasses but has to be in the same package. Protected मतलब हमने उसको protect कर दिया है और बाहर के पैकेज में available तो होगा लेकिन you have to use the child classes. Okay. Subclass means child classes. This is a rule. I'll go through this. So inside the same class, if it's public, available everywhere. Uh, if it's private, I think this is how we read it, column wise. Yeah. Public, available everywhere. Private, inside same class, yes. That's it. Not available anywhere else. Protected, inside same class, yes. Same package, non subclass, different package, yes. Different package, non subclass, no. No modifier, which means it's default. Available in the same class, same package, different package, no. Okay, so I think the order should have been. It's gonna to avoid confusion. I think I should put default at the last because that's the order in that chart also, right? So I think even if we read this, it's fine. Just the explanation of the same thing here. Did we miss? Yeah. Let me just fix this quickly. Animation. Okay. Carry on.
Java runtime system looks for packages from three parts. Current folder. First, the Java runtime system uses the current working directory as its starting point. If your package is in a subdirectory of the current directory, it will be found. Class path. Second, you can specify a directory path or paths by setting the class path environmental variable. Third, you can use the class path option with Java and Java-C to specify the path to your classes.
So this one basically talks about how to find a package and it talks about the path and stuff. So this is what the system will follow. First, it'll look in the current folder. Then, if you have specified the class path, it'll look at that. In case if we use class path option, then it'll look according to that. So let's take an example. For example, consider the following package specification: package mypack. In order to in order for the program to find mypack, one of the three things must be true. Either the program can be executed from the directory immediately above the mypack, or the class path must be set to include the path of mypack, or this must be specified. So all is just saying that any of these things, three things should be true. It should be able to find either in the current folder if you have specified the class path, or if you have used this parameter option, then it will be able to find it, otherwise it won't. When the second two options are used, which means these two, class path must not include mypack. Okay, so here you can see that mypack is not used when trying to access that. It must simply specify the path to my pack. For example, in a Windows environment, if a path to my pack is this, then this is how you write it. So if it's inside of my programs, then Java, and then the name of the package. If you're using these two options, either class path or class path with the option, then you will not specify the my pack. You'll just put the path up until that particular package. Okay, let me again fix this. Okay, types of packages and creating a package. How would you, first of all, how many types of packages are there and how would you create a package? There are two types of packages in Java. Samaya, please read.
Built-in packages are packages from the Java application programming interface that are the packages from Java API, for example, Swing, Util, Net.io, AWT, Lang, Java, etc. etc.
Okay.
Importing a package, import package.name.star. For example, import java.util.star.
Star means then import everything, all the methods. But if you specify a method, it will only import that method.
A user-defined package, create your own package. Creating your package. A package can be created by using the keyword package followed by the package name.
Okay. So there are two types of packages in Java. First is built-in and second is user-defined. If it's already a built-in package, remember we use scanner, right? The scanner is a part of the java.util dot scanner, right? So if you want to import a package, we can directly use import keyword, package name, and if you want to import all the methods or all the classes, we can use star. If you want to import a specific, like in that case, I just wanted a scanner class, then I'll just use scanner. In case if you don't want to use the built-in, if you want to create your own, you can just use package and the name of the package. So let me give you an example quickly. IntelliJ. What system are you using, Mac or Windows?
Windows.
Okay. Let's see if I have an example here. Main HTML file section handling. Yeah. So here, let's say over here, you want to call it your own package my main or whatever you want to call it. You put it like that. But if you want to import certain packages, like for example here I want to import everything from java.io, so I use import then java.io and then star. If I want to import only a certain thing, a certain class, for example from util, all I want is just date, so I'll just do java.util.date and we use the import keyword, and then I can directly use that over here, like new date and so on and so forth. That's how we did for scanner class also. Mm, yep, that's fine. Continue. Here we go. Yeah. Okay, so let me explain this part. So to create a class inside a package, first declare the package name as the first statement of our program, like I just showed you. Then we can include a class as a part of the package. So name of the package to be created, like I created package, name of the package, and then the class. So this class will now belong to this package. If somebody wants to access your custom class from outside this package, they can do it using this first package dot welcome. Okay, this is just a normal print, so it's fine. So in order to generate above desired output, first we use the following command as specified. To generate the output of the above program, java welcome.java. The above command will give us welcome.class. java-d.welcome.java. So this command will create a new folder called first package. Java first package.welcome. The above will give the final output of the example program. Okay, so these are like the steps to generate your package. Okay, I think this will do this as last for today. Interface is important. It's part of the assignment questions. And let's fix this quickly. Can't we apply this to the entire file sheet? Okay, let's read this, Sumaya.
An interface in Java is a blueprint of a class containing static constants and abstract methods.
So this is the same definition we read when we were doing the types of data in Java, where we said that the non-primitive data types are classes and interfaces. There's one more, I think, I don't remember. So that's the same definition. So class is a blueprint which you can use to create objects, and interface is a blueprint of a class. As simple as that. And it has static constants and abstract methods.
In Java, an interface is syntactically similar to classes, but they lack instance variables, and their methods are just declared without having any body.
Right. What are instance variables, Sumaya?
They're object variables
Uh-huh. So are they declared inside the method body or outside?
in outside.
Correct. So an instance variables are the ones which are declared inside of the class, but they are not declared inside of the body. If it's declared inside of the body, what are those called?
Local variables.
Correct. Absolutely. Those are called local variables. Okay, cool.
It means that the interface can contain only constants declaration, method declaration, default methods, and static methods.
Okay. So these are the like some rules that it can only have constant declaration, method declaration, default methods, and static methods. What are the advantages of using an interface?
It is used to achieve total abstraction.
Okay, there is one point which we discussed in the previous slides about the advantage of using interface. Do you remember it? Okay, let me give you some.
It can be used to achieve multiple inheritance.
Absolutely perfect, perfect. That's correct. It is used to achieve total abstraction. Okay,
Since Java does not support multiple inheritance in the case of class, by using an interface, it can achieve multiple inheritance.
same thing which you said. Okay,
It is also used to achieve loose coupling.
right. Okay, difference between this is an important. This is asked in the assignment, so I'll go with this. Abstract class can have abstract and non-abstract methods. Interface. Okay, let's just first come back to what an abstract class is. Do you remember what is an abstract class? Just a few points.
It's a class that is inherited and it's not used as is.
Yeah, it cannot be instantiated. It can only be extended. You can create a child class out of it, but you can't create an object out of it. Any other point you remember?
It's used for abstraction. Don't
Right.
remember anything else.
Right. One more thing is that if there are, let's say, two methods inside of abstract class, any class, any child class that's instantiating it, sorry, extending it, must implement those all those methods. So child class has to implement. If there's a remember there was an example called run, which was declared as static method, and it has to be implemented in the child class. It's a requirement. And an abstract class can have constructor methods also. It can have static methods, all of that. An interface is basically a blueprint of a class. Okay, cool. So we'll go on. Abstract class can have abstract and non-abstract methods. Interface can only have abstract methods. Since Java 8, it can have default and static methods also. Okay. What's the current version of Java? You know that?
I don't
Java 8
remember.
only. Yeah, it's Java 8 only.
Okay.
Okay, abstract class doesn't support multiple inheritance. Interface supports multiple inheritance. That's one of the advantages of that. Abstract class can have final, non-final. static and non-static variables. Interface can only have static and final variables. If a variable is declared as final, it's treated as constant. Okay, and abstract class can provide implementation of interface. Interface cannot provide implementation of abstract class. I don't know what is the meaning of that. But implementation of interface.
Abstract class can implement an interface, like inheriting an interface.
Okay, it can't inherit another interface. It means, but abstract class can inherit, which means it can create the child classes. Okay. The abstract keyword is used to declare abstract class interface. This is very simple. I think this is a very quick thing we can use as a difference. Abstract class can extend another Java class and implement multiple Java interfaces. Interface can extend another Java interface only. So it can extend. I don't know what's the meaning of this. But anyways.
It
An
can't
abstract
extend a class, they're saying, I think. They can extend only another interface.
Oh, okay. 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 The abstract class can be extended using keyword extend. Oh, okay. Use implement here. All right. A Java abstract class can have class members like private protected. Members of Java are public by default. Okay. Example, public abstract class shape, public abstract void draw, public interface void draw. So this is public by default. Okay, fine. Okay, I think we should end it here today. So I need one help from you. I believe you already started the EX207, right?
Database
Which is the
management,
database.
I did
Yeah.
only 4 units.
Okay, so whenever you get to, I don't know if you've got to the ER diagram. Have you got to the ER diagram?
Yeah, that is unit 3, I think.
Okay. And are you able to solve all of these on your own, or you still need to study this? This is
I
creating
solved
ER
them, but I
diagram.
looked at the solutions.
Okay. So I want you to be able to, in a condition that you can explain basically as well. Um, I have read about it, but I find it a little bit complex. I mean, of course, these are easy, but then converting them into tables and all that, probably that requires some time to be invested here. So when you get to it, then we can conduct a session that you can take where you can solve all of this, using that online tool which you had created, where you can draw and stuff.
Okay.
Okay.
I
So I
understood
think,
the examples in the book, so maybe I can do those.
okay. So can you do this on Saturday? I think we'll have more time there. We can have two sessions, one for whatever we're doing, and second for especially for this one.
Yes.
Okay. So 5 p.m. work for you?
Yeah.
Okay, fine. So I'll send an invite for that. So maybe you can. I think I'm thinking maybe they'll ask this question in exam. It's just not very difficult. So yeah. And I've reached till types of file organization here, so I'll share this with you as well.
Yeah, I'm
I'll
on
stop.
the same
Already
unit.
have this?
No, I'm studying
You
the
study.
same unit.
Okay, let me stop the end broadcast.